Okay, last section in chapter 15 is on heterogeneous aqueous systems. So remember, we just talked about homogeneous aqueous systems. So we talked about solutions where the mixture is uniform in composition and the components are evenly distributed. So heterogeneous is exactly the opposite, right? What is a heterogeneous aqueous system? Well, it's when the particles are not evenly distributed, there's not a uniform composition. And that's a vocabulary word that we did way back at the beginning of chemistry sophomore year. Now what we're going to do is we're going to break this up into two different subcategories. So there's two different subcategories of heterogeneous aqueous systems. One is called a suspension and one is called a colloid. And so what's the difference? A suspension is a mixture from which some particles will settle out upon standing. So this is a mixture from which some particles will settle out upon standing. Right? A great example of this is something like muddy water. If you actually get really muddy water and then you just let it, sit undisturbed in a jar for a number of days, you'll notice that those mud particles will settle down to the bottom. Why is that? Because those particles of mud are relatively giant compared with the size of a water molecule. Now, a colloid is still considered heterogeneous, but the particles are much smaller. And what that means is that the particles will not settle out. So a colloid, a mixture whose particles are intermediate in size. So will not settle out. So if you were given an unknown substance and you were told it was a mixture and you needed to decide, well, is this a suspension, a colloid, or a solution? The first thing that you would do is you would let it sit for a while. And if you let it sit for a while and you saw that some of the solute settled down, you would know that it's a suspension. But if you let it sit and you notice no matter how long I let it sit for, nothing seems to settle out, you really wouldn't know whether it was a colloid or a solution unless you tested it. And the test that we use is a test for the Tyndall effect. The Tyndall effect is defined as the scattering of light particles in a colloid or suspension. So the scattering of light particles in a colloid or suspension. Right? So this is really when you take a laser, like a laser pointer will work for this, a flashlight, any strong beam of light will work. And if you shine a beam or a laser through, let's say, a solution, you will not see this light in there. Okay, if you just think of a laser pointer right now and you were going to point it across the room, you actually wouldn't see the laser coming out of your device, right? You would see where it points to on the opposite wall, but you wouldn't see that light going through the air because air is a solution, right? But what if it was a really dusty room or a really foggy day? Or when you go to like a laser light show, they purposefully put fog in the room. What they do is they make that room, instead of being air, which is a solution, they make it into a colloid. And because of that, you can see the beam of light going through. This table right here just sums up the difference between a solution, a colloid, or a suspension. right? The solution, what are the particles? They are incredibly small, right? They are on the same size as a water molecule because they are molecules. In a colloid, they're usually larger molecules. And then in suspensions, they could be, big molecules, but really usually they're groups of molecules. They're actually, like mud. They're groups of particles together. So is kind of think of this as small, medium, and large, right? And so just like, with Goldilocks and the Three Bears, the medium colloid has properties of them both. So a colloid and a suspension will both exhibit the Tyndall effect, but a colloid and a solution are both stable. If we were to put this through like a coffee filter, a solution and a colloid, the solution goes through. The particles are not retained on the filter paper, but both colloids and suspensions are considered heterogeneous. Okay? If you think of the AP test, how am I going to be quizzed on this? This would be like a multiple choice question where they would ask you something about, they would give you some data, something about like the Tyndall effect, and then say, from this data, do you think that it is a suspension, a solution, or a colloid?